Hello, everyone. This is Victor Danchev, CTO at EnduroSat. Thank you for the invitation, and I'm very happy to talk to you about our own innovation story, which is how we started and established the company in just 6 years, and our view on the technology and NanoSat technology of the future, and how it is going to grow and expand with more and more applications. So at EnduroSat, we don't consider ourselves to be that much of a supplier as much as an R&D powerhouse that happens to supply systems. We are extremely oriented towards engineering, and the majority of the people in the company are engineers and scientists. And I would like to share with you just a few of the main points that I believe made us what we are today, and to share a little more about our story and how we got to where we are today in 2021. So first of all, what we do at EnduroSat, we design, build, of course, qualify and fly exceptional nanosatellites. And it may sound weird that I'm saying it, but we already have more than 200 systems in space that can confirm this, and with more than 120 customers globally around the world. We started in the sector only from subsystems, and you're going to find out a little more about those as well. So from individual power systems, communication systems, data handling, and so on. But we quickly expanded into satellites. And one of the things that we are proudest of is the fact that we can deliver end-to-end to our customers today, nanosatellites up to the 12U class, which is the newest type of satellite that we have started building. To give you a brief summary of our story, we were founded in 2015. And we were founded in the country of Bulgaria, where we're still operating our primary R&D office. And just to give you an idea of what life is in Bulgaria, there is no space agency. And up to that time, there was no space initiative. Until that moment, the only satellites which Bulgaria had launched into space were large geostationary satellites for TV broadcasting. And those were by private companies that do basically TV broadcasting. So we were completely new in this segment, and we've had to face a lot of challenges because of this. What we're really happy to share with you is that throughout this time, we since 2015, we have kept a very fast growth pace, and this is the thing that really made us innovate the way that we did, because we didn't have the capability to raise the large kind of funding that you can do in many other places around the globe where industry is already established. So we really had to innovate and go to market really quickly. We had just about one and a half years until we started selling products. So we actually went to the nanosatellite store, and we established our own store for products. And in 2017, we already had customers that were buying our first subsystems and which were using them and starting to fly with them in space. So it took us another year to actually get these subsystems, and we had a lot of lessons to learn from building subsystems to get into platforms. So it took us another year really to integrate these into our first generation of nanosatellite platforms and to launch our first successful mission in 2018. Then it took us another 1 year until we can really expand to the high throughput and high data rate systems that we currently have on the communication side, and to launch our own data services and to really start servicing our customers on a data level. And since 2019, we have been focusing our efforts and goals into really establishing nanosatellite as a commodity product, something that's very simple to integrate, very simple to use. And we have grown in 2021 to our newest and I dare say most interesting service called the shared satellite service, where our ideology is that you as a customer should never even build the satellite. You should never even worry about how it works, but literally give us your payload and start getting data from space. So this is something that I'll talk about as well. Throughout this time, we've managed to grow more than twice every year, both in terms of people and in terms of systems in space, and in terms of the company goals. And as of 2021, we are already nearly 100 people. So it says 80 people on the slide, but we are literally hiring on a weekly basis. So currently it's more like 95 people, close to 100. What is our vision at EnduroSat and what is our purpose is basically to get people to space quickly and efficiently and without any kind of risk. So what we have done in the last 1 year is we have transformed a sector where typically you need several years to get from an idea to a case study to an actual mission. And we have tried to transform it into a way to get to space in just a few months. The way that we've done this is with what we call the shared satellite service. And the primary idea of it is that we actually fly platforms every 90 days. So starting from June this year, we have pre-booked a large amount of flights, and we already have more than 9 flights in the pipeline, which are being registered, which are being worked on, and which are being integrated without having the final payloads. So when a customer wants to fly a new payload, they come to us and we already have the platform ready on the table. We already have the constraints that we know each platform can provide. And we literally give you a catalog of flights, which you're going to see in a second, to get to space. This, of course, is enabled only by the fact that our satellites are software defined. And I'm going to emphasize this quite strongly because we really believe in the software definition of the architecture, not only from an RF side, not only on the radio link, which is the classical meaning of the software definition, but in general. And of course, we can guarantee this because of flight heritage of the subsystems, because of the flights that we have had. So far, we ourselves have operated 3 of our own satellites, but we have had customers that have operated more than 5 additional platforms. And we are happy to say that all of them have been successful. So what do we mean by a software-defined architecture? Basically, it's a way of integrating subsystems without having to custom build them for a specific mission. So all of our subsystems, not only the radio modules, are made in a way that you can reconfigure almost the complete performance of the system just through software updates or even software configurations in the same build. So what is the idea behind? Well, we provide all the standard interfaces. We provide all the standard requirements in terms of both hardware and software so that when a new customer comes on and they want to integrate a new payload, be it an Earth observation, an IoT, or any of the other standard, or even something that's completely non-standard, like an in-orbit demonstration of a payload, what we need to do is, of course, if we can fit it mechanically, we just need to find the right interface, which is already present in almost all of the cases, and to provide them with all the automation needed to actually start working on our satellite. Now, one of the big breakthroughs in our software-defined architecture is that we do not have to integrate any subsystem starting from scratch. So those of you who are in the software side, you know that any new subsystem you integrate, even if hardware-wise it's compatible, you need to start writing a new driver and you need to start working on it. And you basically need to increment your own system with all the functionalities of how you contact that other subsystem and flow down any functionality that it has to your own subsystem. This is one place where our satellites really excel because the way that we handle it is through something called an IDL, interface design language. So any customer that integrates EnduroSat's protocol into their stack is able to fully integrate into our platforms and fully automatically get a driver for their payload, including, but not limited to the mission operations side, only by describing all of their commands in this interface design language format. So instead of having to integrate every payload from scratch and having to integrate every command for it and to test all of this, you just need to describe all of your commands once you have EnduroSat's payload stack, the protocol stack. You just need to describe them in a simple IDL file, and then everything else is automatic. You get immediately an integration to the platform. The platform can use all the commands and interpret the data of your payload. And of course, you can also use this in our mission operations and graphic user interface. So what is the benefit of this? Well, first of all, any customer that integrates the EnduroSat user protocol basically is able to immediately start sending commands to their payload, to receive telemetry from the payload, and to even operate it through our own cloud segment, to EnduroSat's own cloud segment, without any additional integration or any kind of additional overheads. And of course, the main feature of our platform that allows us to run multiple payloads on every single mission is the fact that we have significant space. Just to give you the example, 4.5 units on a 6U CubeSat. So this is about 4.5 liters of available space just for the payloads. Last but not least, one of the innovations that we have made in the last 1 year is that apart from the primary onboard computer on the satellite, we have started including dedicated payload computers on every satellite, which run Linux and which allow you to run custom Python scripts. So not only Python, of course, but this is the preferred language for any kind of data analysis and any kind of machine learning. So you don't just get the avionics, but you also get an ability to actually, without having any kind of background knowledge on satellites, to run scripts directly on the NanoSat and to execute and analyze data in space. So how does the shared satellite look like? Well, this is the schedule that we have. As I mentioned, we have missions which are already pre-booked, and this is just some of the missions dating to the middle of 2023. But we have multiple missions on Falcon 9, multiple missions on Spectrum, and all of these, they're different orbits, which you can literally select from a catalog. So what you need to do is you just go online to our website and you can select the mission. You can see the orbital data which is available for it, the available slots, if there is still availability. And once you book, you're going to be connected to our system engineering team that are going to give you information on any kind of details. So how does the SharedSat work? Unlike most of the hosted payload services, we allow you to choose the kind of operations that you want to do. And the satellite can automatically trigger your operational mode, which is once again something that is fully configurable. So we don't build a software from scratch for every single mission. We have a framework of operations which has all the basics set up, and you only need to configure how do you want to point, what is the kind of power that we should expect in your mode, and any kind of constraints that you have. For example, if you have an Earth observation payload, you would probably want to point to nadir, or you would like to do some kind of target pointing. And maybe you have constraints that your camera should never point to the sun. All of this can be described and can be configured without you having to write any additional lines of code. And if you support the EnduroSat protocol stack, which we provide as a reference, then all of the integration of your payload commands are immediately going to be part of our ground station service. So as soon as you do this, as soon as you give us your payload, we integrate it into our platform and we provide you just with an account. From space, as soon as the launch is complete, you just start getting your data in the account and you can schedule commands based on the ground stations that we're operating the satellite with. So this comes only for our 6U and 12U platforms, but apart from the shared satellite service, so we offer the shared sat service with our 6U and 12Us, but apart from it, we also have the same type of protocols and the same type of integration for all of the smaller platforms as well. So depending on the size, we start from 1U and we have also 1.5, 3U, 6, 12U. Depending on the size of the platform, you can go to lead time as low as 2 months. And depending, of course, on the kind of accuracy and ADCS requirements for the large platforms, this can go up to 6 months. Now, the best thing about it is that once you integrate the protocol stack, any kind of modifications to your payload, any kind of updates you want to do, which is also, by the way, included. So software update is part of the protocol that we support. They are off the shelf integrated into the ground station and into all of the other subsystems. So any subsystem in our satellite can actually request data and send commands to your payload. This also makes for a very redundant system. Unlike most classical satellites, where everything is handled by the onboard computer, the EnduroSat platform's multi-master architecture allows you to really use all the modules to their full extent. Even if the onboard computer is unresponsive or not present, you can still use all of the other subsystems in the satellite to connect to any of the payloads available as long as they're integrated on the same stack. And of course, apart from the satellites, our original logic and the reason why we are enabled to make this kind of software-defined architecture is all of our subsystems. So we offer all the different subsystem types, power modules, communication, structural antenna and communication, solar panels, and onboard computers. And of course, all of these have flight heritage or have been fully qualified for the latest versions. And you can find out more about them on our website. The reason why we are doing what we do is to get you to space as easy as possible. But of course, we understand the fact that sometimes the customer also wants to build their own satellite from scratch. So thank you for your time. This is why we believe that software-defined architecture is the future of the nanosatellite world and the satellite world in general. And the advice that I can give to you in your developments and your future work is, first of all, break as many systems as you can, learn by trial, iterate like crazy. And second of all, make sure that at all times you're perfectly certain that your system can scale, and anything that you do in space, you can always expand and learn from and grow. Because a frozen type of satellite that stays the same and that doesn't evolve is already something of the past. In the modern era, we want ever higher bandwidth. We want to integrate the newest algorithms. We want to have the newest technology. And the only way to achieve this and to be fast enough and to be ahead in this space is really through software-defined systems and software-defined architecture. Thank you.